In this tutorial, we will cover how to create and use AutoML experiments. AutoML is a way for us to easily complete machine learning tasks with only basic knowledge. This is an ideal way for users who do not have deep machine learning knowledge to create powerful models. For users with more experience, this tool can be used to test multiple algorithms and setups more efficiently. In the first portion of this tutorial, we will show you how to create an AutoML experiment. In the second portion, we will go through an AutoML project with already created experiments. To create your first AutoML experiment, we need to click in the top right-hand screen of the page. Once we see this page, first we need to name our AutoML experiment. Next, we need to choose the ML problem type. If you are trying to predict a numerical value, we select regression, and if it is a categorical variable, we select classification. Next, we need to browse for our dataset. We can either choose a dataset from the project, or we can choose from an external Databricks table. In this case, we will browse the datasets from this project. Next, we need to select our target column, or the column to be predicted. When an AutoML experiment runs, it also saves its model to the DBFS, or any file system that you have installed. So we need to show it the save path which we want. The final option is to select our AutoML package. We can either choose PyCaret or H2O. This will affect the number and the type of algorithms that are available to us in the next step. Now we can hit Next in the bottom right-hand screen. Now we need to select the algorithms which AutoML will test for. The more algorithms we select in this step, the longer it will take for our AutoML experiment to run. However, by selecting more algorithms, we also give ourselves a better chance of getting greater performance. Next, we need to select our feature columns. Here, we need to make sure that we do not select the column which we chose earlier as our value to be predicted. Next, we need to set the maximum number of models. In this case, we'll increase it to 5. Next, we need to select the columns to categorical. If you have categorical columns in your data, AutoML can automatically index these into numerical values. In this case, we already only have numeric columns, so we do not need to select any here. Next, we can choose our seed. This will ensure that if we run the experiment multiple times, we will get similar results. Finally, we have two other important options, our stopping conditions. AutoML experiments can take a long time to run, and to make sure that you do not put unnecessary load on your machine, it is important to set a timeout. This will be the number of minutes after which the AutoML experiment will stop. We can also set the number of trial runs. This is the number of runs that the AutoML experiment will go through on each execution. Now we can start our AutoML experiment. Here in the training page, we can see that the job has been submitted to the cluster and that it has received a run ID. Now we can hit back and the AutoML experiment will run in the background. Now let's move over to a project that already has AutoML experiments running. In this project, we can see a few different things. We can see the name of each experiment, the problem type, the target column, and the AutoML package that was used, and the user that it was created by. Now when we want to investigate each of these AutoML experiments, we need to just click on each one. In this case, we will explore an AutoML experiment that is similar to the one that we set up, a regression ML problem type. If we go back to this page, to further explore each AutoML experiment, we need to use the actions on the right-hand side of the screen. The first is View, which is similar to clicking on the AutoML experiment itself. The second is Edit, which will allow us to make changes before we run the experiment again. The third is to start AutoML or to run the experiment again. The fourth is to view the previous executions of the experiment. And the final one is to delete an experiment from this project. In this case, we want to view the previous executions. When we view the executions here, it will show us all of the times that this experiment has been run in the past. Again, we need to use the actions on the right-hand side of the screen to get more details about each experiment. The first is to view the execution result. The second is to favorite the execution so that we can bookmark it for later analysis. And the third is to add a comment. In this case, we want to view the execution result. When you view an execution result, it shows you a few important data points about the experiment. It shows us the database from which we pulled the data. It shows us the Databricks table in this case, and it shows us the target column that was selected. Then it shows us the feature columns, and then it gives us a model summary, including the parameter names and the parameter values. This is important if we want to rerun or recreate the experiment in the future. Finally, at the bottom, we have the leaderboard. This shows us all of the different models that were created or the algorithms that were selected during our configuration, and it shows the associated statistics of the best run of each model type. By using the arrows next to each figure, we can also sort the models in either descending or ascending order. This is a powerful way to see which of the models had the best performance based on the metrics which we deem important. Thank you for listening.